All right.
Apparently, some of you saw the extra credit problems that I posted. So with each one of the problems on there, if you do it and get it right, since there are five of them on there, it's going to be 4 points each. So you don't need to get all five of them right to get points. You can do a couple of them, try them all. Uh, Try working with a tutor. There are some of them on there that are pretty tricky to deal with. So make sure that even if you want to try and do it on your own, I'd still suggest you take it to a tutor afterwards and say, this is what I got. Does this look right to you? Okay. And with that said, we get to start dealing with some more really fun math problems. Some of these are going to look a bit annoying, but how's that any different from what we normally do in here, right? So we've got 8.6 and 8.8. 8.6 is going to be a lot of problems like we've got right now. We're going to be solving for x with the column, or x or y or whatever it happens to be with a bunch of these. And like everything that we do in here, there's going to be some problems where there are special forms. And if you recognize those special forms, you can go in and work out the problem fairly quickly and fairly easily. If things are not in that special form, then you have something that's a little bit more complicated to work with. But the method for working with the more complicated things is exactly the same as with the special forms. It's just you get to skip some steps. So looking at problems like 115 and 116, you can see that they're fairly similar the way that they're set up. One's got twos, one's got fives. Does that really matter to anyone? Not really. It's the same type of material. So let's take a look at how we do 115. Or something like 115. Apparently I can't read that far away anymore. Don't know what's going on here, but whatever. So we're going to do x minus 5, or the square root of the quantity x minus 5 plus 5 equals x. Again, we want to figure out what are the values of x here. With something like this, whenever you have a radical on one side, in general, you want to try to isolate that to make it as easy to deal with as possible. Because whether we've got this or we've got, like we saw the next problems where we're doing a cubed root or a fifth root or a 90 bajillionth root or whatever, we can get the root on one side and everything else on the other. How do you eliminate a square root? What's the opposite of a square root? Squared, right? So once we've got it to some place like this, we can square both sides. That's going to give us x minus 5, or square root of x minus 5 squared equals x minus 5 squared. Squaring a square root, we just get x minus 5. Over here, because we now have the square here, we have to FOIL. And just a reminder that this is going to be x minus 5 times x minus 5. So first, we'll have x times x. Outer, negative 5x. inner, negative 5x last, negative 5 times negative 5. Negative times a negative is a positive. X times x, that's just going to be x squared. Negative 5x minus 5x going to be negative 10x. But again, this is equal to x minus 5. Once we've got it here, we still need to get everything on one side. So subtract an x from both sides. Add a 5 to both sides. Now we've got 0 equals x squared, negative 10x minus x, negative 11x, and then 25 plus 5. It's going to be 30. If we go to factor this, if you see what values we're going to get automatically, awesome. If not, again, go back. X equals negative b, plus and minus square root of the quantity b squared minus 4ac, all that divided by 2a. Let's pretend math just happened here. Because I've got a negative here and I've got a positive here, that's telling me then when I factor this, I'm going to have x minus some value, and then x minus some other value. When I combine the factors together, I get negative 11. Or sorry, when I combine the factors together, I get 11. When I multiply them together, I get 30. We now have an idea about what values of x we can actually be dealing with in here. One of the things that's going to come up with these as well is if we try to, say, graph these things, is it going to graph the way that we really want it to? Maybe, maybe not. So if we, again, look at this first equation here, since I've got square root x minus 5 plus 5 equals x, I can subtract x from both sides. So we get x minus 5 minus x plus 5. I'm just going to say that equals y. If we're going to be graphing things, right? So we can come up here, y equals, clear some of the stuff out. And we've got square root. The original equation was x minus 5. Then pull outside of that, say minus x. And then after we're done with everything, plus 5. I can graph that. And we can actually see how many values of x are there originally. Looks like there might be something going on right in there, right? Can't really see much of what's going on. So let's try to zoom in on there. So window x-min, gonna make that 0. So let's try 0 to 10, see if this helps out at all. Maybe a little bit. Let's change the y scale to, say, -2 to 2. Let's try that one more time. -2 to 2. So what's it look like we've got here? 0, 1, 2, 3, 4. Something's happening weird at 5, and then something's happening at 6. Isn't that kind of what we just found? So keep in mind, did I do any factoring here? Or did I just move things around so that I could graph it? And when we look at the answers that I got originally, x equals 5, x equals 6. One of the things that, or some of the things that actually come up on uh, the exams, I'm not sure which one it is, but they're one of the exams from the class last year. A lot of the students had some serious issues getting the values for x. If the students in that section had actually just graphed everything, they would have seen what the answers were. So knowing how to graph these can be really, really helpful because it's a lot easier to get to the right answer when you know where you're going, right? When we look at problems like these, same thing is happening. We want to isolate the radical on one side, which is what we do going from here to here. Because this is a cubed root, you cube all three or both sides. And then go back and try and figure out, okay, what are the correct values for x? Is there more than one? In this case, it's telling us the solution is x equals negative 13. Something to keep in mind when, or potentially when we have some of these cubed roots, there is a possibility that you will have up to 3 different values there. It's just that some might be real values, some of them might be complex values. So we take a look at what we've got here. Just going to run through 117. So again, we've got a cubed root of 4x minus 3 plus 8. Then I'm saying that equals 5. So if we want to graph this, again, this is going to be the cubed root, 4x minus 3. We have to move this to the other side, so negative, subtract 5 from both sides. And then I'm going to just call this y. So let's see what values we get when I try to graph that. So coming out here, clear all this stuff out. So with the cubed root, I can go to math, and then down here to where it says where you've got this little cubed root thing. And it even looks like I can get everything on the screen at the same time. This might actually work out then. So 4x minus 3, and then I have to pull this value out and say plus 3. And graph that. This isn't helping much, so I need to go back to, say, my original sized window. So negative 10 to 10, and then say negative 10 to 10. Try graphing it again. And we get some things. And if you notice, one, it kind of looks like an S. It also looks like it might pass through the x-axis somewhere out here. So like negative 1, 2, 3, 4, somewhere between, say, -5 and 6. Let's see what happens. So we already have an idea of what the answer should be. So let's see what happens when we actually try doing out the math on this one. So again, we want to isolate the radicals. So I'm moving the 8 to the other side. Cubed root of 4x minus 3 equals 5 minus 8. So that's going to be a -3. I need to undo the radical. We're doing a cubed root. So how do you undo a cubed root? Well, you cube everything. Once you do that, over here, we get 4x minus 3 equals, and on the other side, -3 cubed. When you're doing a problem like this, and you're cubing both sides, you have to keep in mind that the cube here applies to the negative and the 3. For cubed root, what is the difference between this versus this? It's exactly the same thing. But what is the difference between, say, -2 squared versus -2 squared? -2 times -2, that's going to be 4. Here, this is 2 squared, 4, but there's the -1 out, or the negative out in front. So sometimes we have to worry about this, sometimes we don't. -3 cubed. Well, 3 times 3 is 9. 9 times 3 is 27. So you have -27 here. Still trying to get that x. Move the 3 over. 4x equals -27 plus 3. So -24. You still need to get the x by itself. So divide both sides by 4. -24 divided by 4 is -6. What was our graph trying to tell us? -1, 2, 3, 4, 5. So like -5, -6, somewhere in here, it's actually where our answer is. So yes, right? Graph it, see what the answer is, then maybe try to go and math it. So what are they doing here? This is just saying take the 4th root of this, but they're rewrote it a different way. It's the same thing that we've done before. Looking at what we have here, if we were going to try to graph this and figure out what values of R we should be looking for, we can just take this straight up, put it into the calculator, and figure everything out. But what are we actually supposed to be doing with these? Again, we want to isolate whatever's over here, take this stuff, put it on the other side, square both sides. So this is literally the same problem the first problem we did today. It's just they decided, hey, we're going to put 2 things on one side instead of just one. Almost scary, right? And because of stuff like that, looking at what we have here next, again, we want to get the radical by itself, move everything to the other side, and then eventually, well, let's try doing one of these. We'll say this one a couple different ways. because it is pretty much the same thing we've done before. It's just that there might be two different ways to do it. Are both ways going to get you the same answer? Absolutely. Are both ways going to be equally easy to deal with? Absolutely not. So let's take a look at this one. So we're going to do this one 2 times. So 2 times the square root of 4a minus 4 minus 16 equals 16. Like I said, we're going to do this 2 different ways. So with either way, move the 16 to the other side, graph it, instead of the 4a, make it 4x, see where it's going to go through. Yeah. It's 4a plus 4. Is it? Yeah, I don't know that it matters, but whatever. We'll use the one that was in the book. So looking at what we've got here, again, try to move or isolate the radical. So using the same idea we had last time. So we've got 2 times the square root 4a plus 4 equals 16 plus 16, 32. Because we've got this value out in front here, and we still want to try to isolate the radical, we can divide both sides by 2. So we have 4a plus 4 equals 32 divided by 2. So that's going to be 16. What's our next step here? We need to get rid of the radical. So we square both sides. Over here, we're going to have 4a plus 4 equals 16 squared. We'll look at what 16 squared is in a moment. If we're going to do this the other way, still we want to try to get the radical by itself. But from that point, what was the first step that I did over here? Try to get the 2 by itself. Do I need to? Is it important that I move the 2 over? No. Because I can come out and square this. And I will have 2 squared times square root of 4a plus 4. That'll also be squared equal to 32 squared. This 4a plus 4 is going to give us that. But then we're going to have 2 squared out in front. So 4 times 4a plus 4, blah, blah, blah. Could we eventually get to the same spot? Yeah. Is it going to be the same moves? Yeah. But does this already look a whole lot worse than it does over here? So eliminating things first is usually a good idea. Anybody remember what 16 squared is? You're supposed to say, yeah, I totally do. Yeah, let me think. Carry the 1 and 256. Subtract 4 from both sides. 4a is 256 minus 4. So that's 252. Divide both sides by 4. And a equals Well, what's 252 divided by 4? So on this one, it would be a little bit difficult uh, to try to graph it and see where it's going through. But is that something that you could do? Absolutely. You just have to change the window that you're looking at, and eventually you get it. But with this problem, you might end up spending 20 minutes trying to figure out what is the proper window so you can actually see what the answer is. So maybe not quite as useful, but it's still something you can do. Looking at these, we've got a cubed root and a cubed root and a cubed root and a cubed root. In this case, we've got a radical on one side, we've got another radical on the other side. What do we do? How do we undo that? Cube both sides. You go through when you cube both sides, you end up with what? 5x minus 4 equals 2x plus 5. We've done some stuff like that before. And for something like that, let's see. Not much that we need to worry about here. So in this case, we cube both sides. And again, we've got x's on both sides now. Depending on the way you move these things around, you can either make it really easy on yourself or really difficult on yourself. Between 5x and 2x, what's bigger? 5 or 2? 5, right? So, going to keep 5 there. Going to move 2x to the other side. Because I moved 2x over here, got to move 4 to the other side. 5x minus 2x is going to give me 3x. 5 plus 4 is 9. Divide both sides by 3. And that one looked kind of horrific, but is it really that bad? No. Next one. So like with all math, things get worse. So what we end up doing here is we've got 2 different radicals. If we were to put all the radicals on the same side and we go in and square both sides, that is a thing. You will regret that thing, but that is a thing. Unfortunately, the way that these are set up, it's either a horrendous thing or a worse thing. And I'm looking at 128 right now. So assuming that I actually wrote it correctly, that's what we have. And like I said, if you try to put the radicals on the same side, so I'm just going to go ahead and do that over here. Do not do this. Seriously, just say no. Just say no. Now, how do we get rid of radicals? Because these are square roots, we can square each side. Over here, we are going to have square root of x plus 2 squared. Then over here, we are going to have the square root of x plus 16 squared. Getting rid of this, easy enough. Over here, we will have to FOIL. So the first thing is going to be square root of x times square root of x. Outer plus 2 times square root of x. Inner plus 2 times square root of x. Plus last, 2 times 2. Square root of x times square root of x. We still have a radical here, so we still need to get rid of that. So trying to isolate this radical again, now I have 4 times the square root of x equals x minus x, which is 0. And then 16 minus 4 is going to be 12. Divide both sides by 4 here. Square root of x is, what is 12 divided by 4? Square both sides. So that was the thing. No. Just no. Why? Again, what do we have to do to undo the roots? We got to square them. So this over here becomes 2 squared. Definitely going to be a 4. Over here, we have to FOIL. And what are we foiling? So this first thing, square root of x plus 16 times itself. The last thing here, negative x times negative x, or negative square root of x times negative square root of x, so positive square root of x squared. What's your inner thing going to be? Square root of x times the square root of x plus 16. Go. Anybody else regretting that move already? Yeah. So can you do it? Yeah. Am I going to spend the next 5 minutes trying to go through that and make sure I did all the math right? No, not even close. And again, with all of these, if you wanted to, uh, you could literally just take this square root of x plus 16, subtract it from the other side, and put into the calculator square root of x plus 2 minus the square root of the quantity x minus or x plus 16. Graph it. See what you come up with. So these Is that making things look even worse? Yes, it is. But what are we still doing on the one side? We're still going to be foiling it. Then you can see, so from where we started, square root of the quantity q minus 2 times 3, you're going to have 3 times square root of q minus 2 plus 3 times the square root of q minus 2 to give you this thing down here. Get rid of the square in the front, square the back term here, so you're still foiling. And then you square it again. And then you just keep going until you get to the end. And then you hope you're done. So let's try 129. So we've got square roots of x minus 1 plus 2 equals square root of 2x plus 6. Again, how do we get rid of the radicals here? In this case, we're going to square it. So over here, we're going to have square root of x minus 1 plus 2 times the square root of x minus 1 plus 2 equals the square root of 2x plus 6 squared so we're going to FOIL some stuff. This thing over here, those two cancel out to give us 2x plus 6. So first, square root of x minus 1 times the square root of x minus 1 outer plus 2 square root of x minus 1 inner plus 2 square root of x minus 1 last plus 2 times 2. These cancel out to give us x minus 1. These combine together, 2 plus 2, 4 times x minus 1. 4 there equal 2x plus 6. We can combine the like terms and move everything that's not a radical to the other side. So subtract x, add 1, subtract 4. So subtract x, add 1, subtract 4. What's left over here? Square root, or 4 times the square root of x minus 1. This is going to equal 2x minus x. So just an x. 6 plus 1 is 7. 7 minus 4 is 3. Do we like fractions? If we try to get the 4 to the other side over here, what's going to end up happening? Have to divide both sides by 4, and then we have to square both sides. And we're going to be squaring fractions. So do we like fractions, yes or no? No one wants to make that call, or no one's conscious enough to make that call. Which one is it? Do we like fractions? And do we like squaring fractions? So in this case, again, in order to get rid of the radical here, we need to square. This is going to give us 4 squared times square root x minus 1 squared equals so over here we're going to be foiling again. So x times x squared, 3 times x, and then plus 3 times x. So plus 6x, 3 times 3 plus 9 equals 16 times x minus 1. So 16x minus 16 equals x squared plus 6x plus 9. What's our next step here? So this is what we're working with right here. Got to collect like terms. Minus 16x. Add 16 to both sides. And eventually, well, I guess I ran out of room here. So I'm going to move this over here. Guess I needed just a little bit more space. So x squared, 6x minus 16x, negative 10x, 9 plus 16. Now we can go in and factor this. And again, because I've got a negative there, I know at least one of these is going to be negative. Because I've got a positive there, I know that both of these are going to be negative. What are some factors of 25 that when you combine them, it gives you 10? So what's the value of x that we can have here? So we get x equals 5, right? Now, one of the things where they can try and trick us up with these is, let's say instead of what we got x equals 5, let's say we got x equals 5 and x equals negative 3. Okay. If I put 5 in here, 5 minus 1 is 4. What's the square root of 4? It's a number we like dealing with, right? Not too difficult. I put a 5 in here. 2 times 5 is 10. 10 plus 6 is 16. What's the square root of 16? Happy number, right? But what if we got 5 and then negative 3? 2 times negative 3? Negative 6. Negative 6 plus 6? 0. What's the square root of 0? 0. We can handle that. Negative 3 and minus 1 is negative 4. I know we've talked about it, but if you try to do the square root of negative 4 in your calculator and you didn't change your the calculator to do complex variables, what's the calculator going to tell you? Error. It's going to growl at you, go error. So we do need to go back from time to time, check our numbers, make sure that they actually work in our original problem. In a case like this, we only have the one value, so everything is fine. But let's say we got through all this and the only values we had were like -3 and -2. What is our correct answer going to be here? Well, if I put in a -3 or -2 here, that's going to be the square root of a negative value. And your calculator is going to get mad at you. So the answer is, there is none, does not exist. You can say it's a complex. How would you do that for the homework? I have no idea, but I'm sure that's kind of an option on there. And again, with all of these, you can graph these just to see where you should be or where things should be coming out at. Uh, so physics applications, see, a helicopter dropped a rescue package from a height of 1,296 feet. Use of the formula equals T equals square root of H divided by 4 to find how many seconds it took to for the package to reach the ground. H is 1,296. So it's the square root of 1,296. Divide that by 4, you get T. Not going to worry about that too much. Let's see. That looks like the end of that section. Get to skip ahead, keep jumping ahead. Be nice if there was a button on here that just said skip to next section and did it automatically. Oops. Yep. So we get to 8.8. So now we actually start getting into complex values. So again, some of these special forms, if you understand the special forms, awesome. If you do not understand the special forms, do not worry about it. Just do what you know how to do, foil these things. So if we're looking at, say, problem 165, so we've got 4 minus square root -12 times 3 minus square root of -49, 48, oops. Okay, with these, what we are supposed to notice is that we can break this down like that. We can break this down like that. Because we've got these square roots of -1, these are going to become i's. So we can rewrite all this stuff here as 4 minus, say, I times the square root of 12. And then 3 minus I times the square root of 48. Our next step here, FOIL first, outer, sorry, inner, And then last, uh, even though, well, these have negatives on here, so negative times a negative is a positive. Even if one was positive, one was negative, I'd probably still put the positive out here. And then just put everything else in the, or try to note which one of these would be negative over here. So 4 times 3. In this case, it's going to be 12. With these two, if you notice, whatever is under the radical is not the same. Because those values are not the same, so hold off on that for a moment. But over here, I've got I times I. So I'm going to have I squared, square root of 12, times square root of 48. Over here with both of these, the way that they're set up, it's kind of hinting that whatever's under the radical should be the same, right? So we kind of expect, I'm going to do this one up over here, or do these up over here so we don't get too horrific with it. Square root of 12. What are some factors of 12 where one of them is going to be a perfect square? So 4 times 3. So 48. What are some factors of 48? That when you break it down, you get a perfect square times some other value. What do we think that other value is going to be? At least that's what we're hoping for, right? So 3 times what gives us 48? So we now know that the square root of 48 can be rewritten as 4 times the root of 3. We know that the square root of 12 can be written as 2 times the square root of 3. So let's plug these back in over here. So now we have 4i times 4 root 3 minus 3i times 2 root 3. 4 times 4, 16i root 3. There's the negative out in front. 3 times 2, 6i root 3. Now that we've got the roots combined, we can go ahead and start working on these. Negative 16 minus 6, so negative 22i root 3. Right now, 12, it's just going to be a 12. Over here, we've got a mess going on. Since I is the square root of negative 1, I squared is the square root of negative 1 squared, which is going to give us negative 1. If we make I cubed, what ends up happening here is we break this down into I squared times I squared is -1. I is the square root of -1. And then I to the fourth, square root of -1 to the fourth power. That's I squared squared. So so some of these, when you look at them, you've got I squared out in front here. I squared is just going to be -1. If I had I squared, or if I had I to the fourth, I'd say 1. If I had I to the eighth, I would say I to the fourth squared. 1 times 1 is 1. I to the 60th power. I to the fourth to the 15th power. So it's 1 raised to the 15th power. 1. I to the 62. I squared to the 16th power. Negative. So you're going to end up what? Well, if I to the 60 is positive, I to the 62 is negative, I to the 64 is positive, I to the 66 is going to be negative, and so on, and so on, and so on. And hopefully there aren't any problems like that, but you never know. It is math, right? So what do we know about this? This is going to turn into -1. We already know that's going to be 2 times the root 3. We already know that's going to be 4 times the root 3. -1 times 2, -2, -2 times 4, -8. Square root of 3 times square root of 3. So -8 times 3. So eventually, 12 minus 22i root 3 minus 24. 12 minus 24, -12 minus 22i root 3. So that's a thing. So looking at what we have here, again, multiply everything out, FOIL it first. So 3 times 3, outer 3 times a +2, so +6 times I, inner, and then last. Then we have to keep in mind that I squared is -1. Negative times a negative is positive. And the thing hath just happened. So if we're looking at this, we can again FOIL it. So if we've got -2 plus 5i, -2 minus 5i. So this is getting back to some of the ideas of the special forms. If you recognize this, it's basically going to be a squared minus b squared. But when we FOIL this, -2 times -2, outer, I'm going to say plus -2 times -5i, inner, plus negative 2 times a positive 5i. And then last, 5i times negative 5i. Negative 2 times negative 2, 4. Negative times a negative is a positive, 2 times 5, plus 10i. Negative 2 times a positive 5, negative 10. And then here, 5 times negative 5, negative 25 times I squared. 10i minus 10i, those cancel. 4 is staying the same. But here, we now have negative 25 times I squared, which is going to be that negative 1. Negative times a negative is positive. So this is definitely another thing that happened. And if you looked at that originally, then you look at the answer that we got, does that look a whole lot more simplified than that? Which, of course, brings up all sorts of questions, right? Like, why would you write it out like that if you can write it out like that? Uh, I've actually seen some people try to make things more complicated than they need to, just to make themselves feel better. Usually they're called mathematicians. So when they start doing that, just pat them on the head and say, good try. Better luck next time. Because they really hate it when you pat them on the head and treat them like a dog. Just saying. Just saying. But again, with all of these, it's the same idea over and over and over again. How do we handle it? You just go forward and foil it. Now, once we get to dividing by complex numbers, doing these types of things, I mean, just look at the first step that we're doing here. What we're trying to do here is, you can see it's called right here, the complex conjugate. With all of these, I zoom in on both of these. In order to make the I in the denominator here disappear, we have to multiply by the complex conjugate of this, which is going to be 6 plus I, numerator, denominator. Here, to get rid of that, we're going to have to multiply numerator and denominator by 5 plus 2i. This is a little bit more of a thing, so I'm actually going to do both of them. And I am going to write them down on the table here instead of over there. So we've got 2 plus 5i divided by 5 minus 2i. And then 1 plus 6i divided by 6 minus I. So we'll work on this one first. Step number 1. Multiply the denominator by the complex conjugate. Then multiply the numerator by the complex conjugate. The denominator we're going to FOIL, in the numerator we're going to FOIL. So in the denominator, first, outer, should be 5 times 2i, inner, minus 5 times 2i, and then last, minus 2i squared. That's going to cancel out. The numerator, 2 times 5, 2 times 2i, plus 5 times 5i, plus 5i times 2i. So looking at the numerator here, collect the like terms. So we're going to have 10, 4 plus 25, 29i, plus 5 times 2, so 10i squared. We already know that I squared is going to be -1. Denominator, 25 minus 2 squared, so 4i squared. Again, we already know that I squared is going to be -1. So the next step here. So again, we have 10 plus 29i, negative times a positive, minus 10. Oddly, those two things cancel out. Denominator, 25 minus -4. So that's going to be a 24, or sorry, that's going to be a 4. In the end, cancel the I or the 29s. And that whole thing is I. And that was definitely a math that happened, right? And just so we're clear, these things in the next section or two, how are these things going to get even worse? Most definitely. How do you make them worse? Well, now you can have like a square root of 3 and square root of 3x and solve for x and blah, blah, blah. But again, here, what's our first step? Multiply by the complex conjugate of the denominator. Which just means we take whatever this is and make it the opposite. So we're, again, numerator, we're going to FOIL. So 1 times 6 plus 1 times I plus 6i times 6 plus 6i times I. Worry about that in a moment. Denominator, again, because this is complex conjugate, it's going to be 6 squared minus I squared. Follows the same type of pattern we had here. So for outer, plus 10i inner minus 10i. They cancel out. Then you take whatever is left here and you square it. So we can make that, again, if you remember the special forms, go ahead and use them. If that seems to be a bit too much, spoil it. You will get the correct answer as long as you do the proper work. So now we have 1 times 6 is 6, plus I plus 36i plus 6i squared. Again, we know that's going to be a -1 there. Divided by 6 squared, 36 minus -1. So we know that negative times a negative is going to give us a positive. Combine all the like terms. So this becomes 6 plus 6 times -1, 6 times -1, -6. So those are going to cancel out. 1 plus 36 is 37 divided by I. 36 minus -1, same thing as 36 plus 1. So 37. What are we left with? I. Will it always work out like that? No. Do you wish it would always work out like that? If we had to really do any wishing, you would probably wish that you never have to do these again, right? So hate it when some of these problems in the math book are like, hey, look, it's really that easy. And then you try to do it for real, and all of a sudden you're like, no, that's not how these work. So with both of these, what is the complex conjugate? You multiply numerator and denominator by 1 plus 4i. Down here, multiply numerator and denominator by -1 minus 2i. Same thing that we just did. Not going to bother doing another example problem like that. We can see here, just one little extra tricky thing here. What's the complex conjugate of positive 4i? -4i. So let's try doing 176, just so we can see how these turn out. Because this is slightly different than we did before, but not very. So if you follow, or if you want to try to do what the book actually did, not sure that we really want to, but let's say we do. What did the book have us do? Multiply numerator and denominator by 0 minus 5i. And then what do you get when you multiply anything by 0? It's 0. Do we need to put something extra in there? I don't think so. If we do it this way, so again, we're distributing, not exactly foiling, but distributing. So we'll have 2 times -5i plus 4i times negative 5i divided by 5i times negative 5i, positive times negative, negative 5 times 5 is 25, I times I, it's going to be I squared. We already know that I squared is going to be a negative 1, so negative times a negative, it's going to give us a positive. Should probably have written this over here, sorry. So the denominator here is going to be 25. 2 times negative 5, negative 10i, plus 4 times negative 5, so negative 20, and then I times I, again, I squared. We know that I squared is going to be a negative 1. So negative 20 times negative 1, positive 20. And all this is going to be divided by 25. Once we've got that, anybody want to guess what the next step's going to be once we're here? What are the common factors? You can pull a 5 out of everything, right? And so negative 10 divided by 5, negative 2i, plus 20 divided by 5, it's going to be 4, divided by 25 divided by 5, it's going to be 5. And I will say, when it comes time to do something like this on the exam, I am completely fine with the answer written like that. But because this is math and sometimes the online homework systems have minds of their own, I'm just rewriting this thing so the I is in the second position. What do 4 and 2 have in common? Well, they both have a 2. Oops, that should be a 2. So it is possible that the online homework might want you to write it as 2 times the quantity 2 minus I divided by, and all of that divided by 5. I don't care. You give me that, you give me that, I will give you full credit. Is anyone else tired of me talking about what the online homework system may or may not be wanting you to do for a homework problem? And is anyone finding that sometimes stuff that I talk about is actually happening when you're doing the stuff on the online homework? Anybody else want to go find the computer programmers that did that and just start smacking them around a little bit, just saying, no, bad programmer, no coffee for you. We'll say, I think it was like 2 years ago now, I actually had a student in a class like this. She actually is in a computer programming or computer science program right now. She kept getting mad when she would go to enter in an answer, and it's like, well, let's go smack some computer programmers around. They're the ones that are doing this. So anyway, looking at what we have here, you can see when you raise I to all these different values, what's going on. When you double those values, you get the same pattern going on. So more than likely for the whole, or for a lot of the stuff that's coming up here, what you end up doing is looking at the power and you break the power down into, if it's even numbers, uh, if it's a multiple of 2, but not 4, so 62. 62 divided by 2, we can get something nice with that. 62 divided by 4, not so much. We're going to break it down as so I to the 62 is going to be I to the 60. 1 times 1 times 1 to 15 times out. Then we're going to have the I squared left over. So positive times a positive times a positive, times a positive times a positive times a positive times a pos times pos times a pos times a positive times positive times a 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 negative. It's a negative. If it's say 63, we can again break it down to I60 times I3, I60, positive 1, I3, negative I. So you can see what they're talking about here, breaking it down, break it down, break it down, break it down. So I to the 75th power, if we break it down to I74, is 74 divisible by 2? Yeah. Is 74 divisible by 4? No. So it's divisible by 2. So 74 is a negative 1 times I. That's horrible, isn't it? So we'll try to do that one real quick. And hey, look at that. After this stuff, that's the end of this material. Yay! So this is basically a table that you're more or less just going to have to remember. So just I to the first power is I. I squared is negative 1. I cubed is negative I. I to the 4 is a positive 1. So if we have I, what was that? I to the 75th power, we have some choices here. We can say I to the 72 versus I cubed. 72, is that divisible by 4? I hope so, because what's 9 times 8? Is 8 divisible by 4? Then this is divisible by 4. So that's going to be 1. What is I cubed equal to? Negative I. We can also break it down I74 times I. Is 74 divisible by 4? No. Is it divisible by 2? Yes. What is negative 1 times I? Negative I. Same thing we got here. Using the same idea, if I have I to the 59 power, I can break this down as I to the 56, I to the 3. 56, is 56 divisible by 4? I'd hope so. What's 7 times 8? So that's going to be a 1. I cubed. It's going to be negative I. This is, or we can do it I to the 58 times I. Is I to the 58 divisible by 4? No. Is it divisible by 2? Yes. So this is going to be a negative 1 times I. I'll try to leave all this up here and only all of this up here just so we can see what I'm talking about here. So you've got a couple different ways to do this. If you're really good and you remember all of your multiples of 4. Anyone remember all their multiples of 4? I wrote I to the 1077th. Do you remember your multiples of 4 all the way up there? I don't either. But we can break it down. So even if I gave you, like I said, something really, really stupid. And when I say, if I give you something really, really stupid, that's kind of code for what? I've seen these types of things on the exam before. So let's say I give you I to the 1077. You can break this down to I to the 1076 times I. And then we can ask, is 1076 divisible by 4? I don't know. Is 1076 divisible by 4? Yes, it is. Since it's divisible by 4. Whoa! A thing hath happened. So I don't know what's better for you. This is going to be something you have to get used to. It is going to be something that I can basically guarantee it's going to be on the exam. This is something where I honestly don't know what's the best thing for all of you. But if we have an even number here, just ask, is it divisible by 4? If yes, 1. If no, negative 1. If we have an odd number, we can break it down like this. Ask, is the rest of this divisible by 4? If yes, 1. If no, negative 1 times I. So again, I'm not sure what is best for like trying to memorize this stuff, but that is the pattern. The other option, should you choose to hate yourself, is what? Remember that I squared is equal to negative 1. And then for 1076, we can rewrite that as what? I squared. So I squared times what? 533. I squared is equal to negative 1. Write out negative 1 times negative 1 and then do that 500 what? Yeah. 530 plus times. And keep track of all your negatives. So again, I don't know what's best. I think that's probably the simplest way to do it. If it's even, divide the power by 4. If it gives you an integer, it's 1. If it's an odd, or if it doesn't give you an integer, then it's negative 1. And then For the odds, you just multiply I by 1 or -1. Anyone else had enough? All right. Doors over there, please use it.